Oh, wonderful. Okay. Yeah, fine to see everybody. Be talking about the web framework I've been working on with the growing and active community for the last few years. It's called Chicago Boss. I'll tell you, in this talk, I'm going to talk a lot of sort of philosophy and engineering philosophy that went behind it. Because if I just talk, oh, let me move my jacket here. If I just showed you the API, it looks kind of similar to other web framework APIs. So it really comes down to a question of why Erlang is so well suited for web development. And there are very specific engineering reasons for that. But before I get into them, I want to talk to you about me, or at least my history in software. I worked for A9.com down in Palo Alto. I don't know if anybody of you has been by there, but if you're on the Caltrain and you go through Palo Alto, you'll see the big A9 sign still there. And I was fresh out of college, and I tried to get a job as a software engineer because I knew somebody there. But I didn't actually know anything about computers or software, so they said, well, would you like to wear a pager for us instead and tell us when our systems break? It's like, oh, okay, that sounds fine. And when I moved out, and my first week on call, I got paged 110 times. And so there are 168 hours in a week, and the crashes of C++ programs are kind of like a Poisson process, so you can imagine that's kind of spread out evenly. And I did not get a whole lot of sleep. So that kind of introduced me to the dark underbelly of network operations and website operations. But of course, it was a lot of fun because I was on a team with 6 other people, and we got to drink a lot and try to drown our sorrows. But I left there to take a job across the street at a company called IMVU. It was starting to be a little bit famous as the first lean startup. There's a really good book by Eric Ries about lean startup practices and continuously deploying new code. And that's something I really liked that they did. They would constantly push new features out because they had really good test coverage. But it's something I'll talk about today is that the formula didn't quite work because the tests were really slow. And if you're trying to constantly deploy something and your tests take several hours, well, people are human. They're going to say, well, I'm sure I didn't break these tests. I'll just push anyway. And pain and suffering ensued. So I got to know all about pain and suffering in Silicon Valley on the operational side and the development side. And that kind of informed or made me want to search for something better, a better platform. Since then, I also decided something that sounded like a lot better than having a job was not having a job. And I went to grad school starting in 2008, and that's where I've been since. I'm working on a PhD in economics at the University of Chicago. So this is just a hobby project. Some people have thought, it's like, oh, there's no company name on Chicago Boss. Is this some secret ops? Like, no, it's just been a hobby. So thought I'd just answer that question. And by the way, in the rest of the talk, if you ever feel like interrupting me or asking a question, please do that, because I really just want to make sure I'm talking about things that people find interesting. So why Chicago Boss? Well, first of all, I want to talk to you about a little bit about the name. This was inspired by a database I was a little infatuated with at the time, one of the early NoSQL databases, Tokyo Tyrant, which was just put out by some guy living in Japan. And I'd gotten pretty frustrated with doing schema migrations when I was working at IMVU. And so NoSQL seemed like a nice, painless solution to the problem of taking down a service in production and moving all the data over, and et cetera. So it's sort of where the name came from in homage to Tokyo Tyrant. Since then, we've supported a lot more databases. But another thing that I liked about the name is that it's kind of political. This is a picture of Edward G. Robinson. Anybody know the movie? Key Largo, 1948 with Humphrey Bogart. He plays a Chicago gangster. I just like this picture a lot, so I thought I'd put it up there. But I think it's important to keep in mind that technology and information and power are very intimately related in our society. And technology it gives us control over nature. It lets us communicate. It lets us collaborate, and sometimes it gives us power, over other people. And I think it's important to realize that role that technology has. Information technology in particular. There's a really good book. Oops. Called The Control Revolution by James Benninger. It's from I think 1983. And he talks about control in a very a technical sense of control theory. Sort of comes from operations research, which basically says that in order to control something, you need good information channels in place. In particular, you need a channel for issuing commands, and you need a channel for getting information back so you can see what you're controlling. So for example, a thermostat will have both a mechanism for increasing and decreasing the temperature, and then a sensor to see what the temperature actually is. And sort of in our society, as we got better information technology structures in place through the 20th century, it enabled us to have much larger organizations, and organizations that could coordinate action over larger and larger spheres of influence. So I just say all this because I think information and control and power are very, very well tied together, and I think Erlang's actually going to play an interesting place in the development of information technology. One thing in particular I think is kind of scary is that we have just a few organizations that are emerging that are controlling the information infrastructure. And a lot of that has to do with economies of scale that they get out of controlling those. And if you step back and think about it, you've just got a few organizations that control most people's representation of knowledge, emails, newspapers, magazines. These are all getting digitized, and they're all being controlled by a sort of a frighteningly small number of entities. And I think it's kind of scary, actually. So what can we do? Well, back in the 80s, there was a guy named Marty McArmstrong who decided to go to the future and get a programming language and bring it back. And that, of course, is Erlang. And I think it's even though it's 25 years old, I think it's still 15 years ahead of everything else. And I think that's why we're all here. And I think it's something that's going to help us build the next generation of information technologies. So what does Chicago Boss have to do with this? It's the goal of the project to reduce a typical website's operational cost by 90%. That's a goal. And it might even be conservative based on the numbers I was hearing from Alex at his presentation yesterday. Very conservative. And what is that, reducing costs, sounds good to everybody, but I think we can actually enable sort of qualitatively a new class of applications, a new class of websites. So right now, to run a popular, well-trafficked website, you need a large organization. Even if it's nonprofit, you need a huge bureaucracy, you need a huge operations team. If you're Wikipedia, you still have hundreds of servers to manage, dozens of ops people, et cetera. So I'd really want to be able to leverage Erlang to make websites that more marginal groups can use, or that maybe just you can build a website and have hundreds of thousands of people use it and not need to build out a big infrastructure, formal legal entity to support it. And as I say here, hosting your own stuff represents power and independence, and I think that's really important. So finally, I'd like to enable sort of a new generation of applications that you can deploy, and that someone can write an open source web application and have it just not need any care and feeding after you set it up and get going. So that's what we're hoping to do with this Chicago Boss framework. So what is it? Here's the analogy I like. Sort of is to Ruby on Rails what Nginx is to Apache, which means it basically is designed to do the same thing, but it's different in two very specific ways that I'm going to talk about. The first is non-blocking network IO. And I'll get into the exact engineering benefits of what that means. But the second that people don't talk about in web development nearly enough is no-copy memory architecture. And I'll explain why for the sorts of applications we have, Erlang actually will do a minimum number of copies. which gives you much, much better performance than you'd have otherwise. So, if you look at information or talks about something like Node.js, they'll keep emphasizing the first one, but it's the second one that'll give you a lot of wins as well. So, in short, we just want to be faster, better, and cheaper. The project started with this project called Early DTL, which is an implementation of the Django template language. It was started by Roberto Sacon in 2007, and I kind of discovered it about a month after his first commit, where it looked like he had done the first 90% of the work in implementing the Django template language, and so it was left to me to do the other 90%. Yes, there's only 90% left. So I want to talk a little bit about why, I'm not going to talk about the syntax of Django. You can go to a Django conference if you want that, but I do want to talk about the memory architecture in implementing a template language in Erlang. And sort of my punching bag will be a Ruby string versus an Erlang IO list. But this is really a stand-in for any other type of string structure in PHP or Java or C# or anything else, anything that's not an IO list. The things that I'm going to say will apply. So the first is, if you want to do a concatenation, or if you want to do an append, so you're building a template, you got the header, now you want to add a heading, or you want to add some other variable. Well, what do? Well, in Ruby, you do a concatenate, string.concat. And if you look at it, it's just a memcopy. It'll say string 2, copy into string 1. Whereas with Erlang, when you're building an IO list, you actually just do a cons operation on the list, which is an order 1 operation. So you've got 2 pieces of memory. You say, oh, well, I'll build a list, and the first element of the list will be this, and the second will be that, rather than getting this and copying it all the way over into here. And that'll give us a number of benefits. If you're coming from the C world, the way that I like to think about it is that a Ruby string is just a pointer, and in Erlang, you've got a pointer to pointers. And that implementation goes all the way down to the network level. So the underlying write function in your operating system, if you open up Ruby, it'll just say, write this pointer to this socket. In Erlang with IO lists, you'll find a lot of write Vs on Unix, which says, I've got all these pointers, just take all the data from all these pointers and send them over the socket. So you don't need to copy them into one large piece of memory before you send it, which is a really great implementation detail that works really well for templates. And a lot of this benefit that we'll see comes from data mutability. And something that Erlang can do because the data is immutable is have a much lower memory footprint. So when you, I think it was starting with R13 or 14, when you compile a module and you have a binary literal, which will be something like a template header, that'll just occupy a constant or a static piece of memory in the binary heap, which means that the shared template snippets will actually occupy the same hunk of memory across multiple requests. And this is a huge win from the perspective of your memory footprint. So if you have 100 concurrent requests in something like a Ruby or PHP, it'll be constantly creating new rendered templates and have a separate chunk of memory for each one, whereas in Erlang with these IO lists, for all the stuff that's shared, it's just a pointer to the shared part, which gives you a better cache hit ratio and that sort of thing. So the practical benefits here are really important. Tests run quickly on rendered early DTL templates. They're really fast. And that means you can just work much faster and be a lot more productive. So it sort of solves the problem that I've personally experienced at IMView, which is that slow tests were just not being run, and you had people just kind of doing fake test-driven development on account of the development speed. The other big benefit, of course, just has to do with using fewer servers to accomplish what you want. And finally, your application logic is a lot simpler. So if any of you are Ruby on Rails developers using the latest version and keeping up with the 37 Signals blog, they advocate using all kinds of complex view cache hierarchies, and you've got to be really vigilant about cache expiration and keeping the cache in sync with the database and that sort of thing. If you can just eliminate the cache because your view's fast enough, then that just eliminates all kinds of application logic and all kinds of problems. So it's a really big win in terms of server-side template rendering. So next I want to talk a little bit about the Erlang VM and sort of the other reason, or the other engineering reason that Erlang is really great for website development. And that, of course, is non-blocking IO. So if you already know everything there is to know about blocking and non-blocking IO, you can check your email for the next couple minutes. But I just want to make sure that everybody sort of appreciates how much this helps. So if when you've got a blocking server, it will basically, anytime you go to the database or do any kind of network operation, you're going to need a separate process to sit there and wait for a result. And in most languages and applications, that'll be an actual operating system process. Erlang, of course, has these green threads or these Erlang processes, which means there's just one operating system process, or typically one per core that you're running on. And as a result, the memory footprint is much lower for handling a lot of concurrent requests. So usually you'll measure it in the megabytes for something like Ruby that has to spawn a separate interpreter. And it'll just be a much lower when it's just a little data structure and you don't have to worry about the stack or any of that. I get in arguments with people, or I haven't actually kept up with Ruby in a number of years. So I'm told they've improved things a little bit with fibers or fibrils or something, but I haven't looked back. So the other big benefit that you get with Erlang is you don't need nested, you don't need all this nested callback junk that people are doing with, Node.js is the hot non-blocking IO server. But you quickly find that you got your scope level increasing every time you do a network request, which just gives you terrible code. And this is just doing 2 network requests in a node, which could also be in an Nginx or another non-blocking server. You get this junk. In Erlang, it compiles essentially to the same thing, which is going back to your select or your epoll or whatever. But the code is nice and clean and sequential, so it's kind of non-blocking under the hood, which I think is pure genius. When I discovered this, I was blown away. And they don't advertise it, Well, it's too obvious. There you go. I had to grep the source code to figure out that this was this is how it actually worked. I cannot say enough about this design decision, which they think is not news, but to anybody coming from any other framework, this is really important. Yeah, you're saying something about publicity earlier. So you get all kinds of engineering benefits, and then your code's not a mess. So practically, what does this mean in terms of a web server? It's where you can put your email away. It's hard not to write a high-performance server in Erlang. You automatically get all of these benefits. You're not going to crash your operating system with lots of operating processes and threads in a way that can easily happen if you have a high-trafficked server and anything else. The second thing is that we get these WebSockets for free, which are real-time notifications. So we can keep sockets open and keep connections open and let our application just pretend like it's this blocking, long-running thing, when really it's imposing very low marginal cost for keeping that connection alive, so we can do all kinds of neat real-time things in our web browser. So the other cool thing, which Joe alluded to in his presentation this morning, is you can build a lot of services into one server, and everything will just continue to work fine, which is really neat if you want to build a comprehensive web framework. So, what does Chicago Boss do? Why are you all here? It's a high-performance web server. It implements Django templates, or about 99% thereof. We've got just a few small incompatibilities, because the Django template language is actually like a functional language. It's very easy to implement, because it's these nice for loops with well-defined scope, no data mutating. It's a really nice little template language. I don't think they even realized it was functional when they wrote it, because I emailed them about some. I wanted them to close some tag which was not closed because it was creating this mutable state. They had no idea what I was talking about. The second big feature is sort of a Rails-like API from your controller and model. And as I alluded to, we've got support for WebSockets and long polling for getting kind of new age web features. A couple other things that we have in there is a built-in email server using GenSMTP, which just really makes your operations a lot easier, because you don't have to get postfix installed, and you don't need all this extra junk on account of having slow servers out there in the world. You can just build it right into Erlang, and things will work more or less out of the box. We also have a message queue, which kind of enables chat services or these WebSocket services across a whole cluster of Erlang nodes, which is neat. So just a few other features, give you a high-level overview. We do really horrible things with the compiler chain in Erlang in order to get features that we wanted. So for example, we've been supporting UTF-8 source code for a long time. And I think internationalization is really important in website development. It's often overlooked, but we've got some facilities for editing your PO files, they're called, and doing the translations and the template tags. We've got a built-in admin interface called CBadmin, which will let you kind of edit the database and look into it and just see what's going on without writing a single line of code yourself. So it'll kind of introspect the models and build you a nice HTML interface to get going. And I'll talk a little more about the data modeling in a minute. And of course, we tried to do everything in a very OTP compliant fashion to get all the benefits of OTP services, of hot code reloading, and so on. So one thing I want to talk about, or one aspect of BOSS, is BossDB. This is our model or database layer. It's actually been split off into a separate project. So if you want to use the Chicago Boss model and database layer, you can. It's pretty easy to get integrated into other projects. So I think it's the only database abstraction layer that there is. At least it was when I started writing it. I couldn't find anything else out there. Now we support 7 databases. We actually, the Concurrix contributed the DynamoDB one recently, so it's be great if more people would try it out and make sure, graduate it from experimental status. But the SQL database drivers are really well tested. And it's really nice just to be able to kind of build your application and then decide later what database you actually want to work with or makes sense for your application. So the most controversial aspect of BossDB is our wholehearted embrace of parameterized modules, which everyone else in the Erlang, or at least on Erlang questions, seems to hate. But it's really nice to have something that looks like object-oriented programming when it comes to modeling database tables. It's just nice to say author : first name and get their first name back. It's especially nice because it can integrate with the template. So you can say something like message.author.firstname, and it'll do what you expect. So like object-oriented programming is actually a convenient mental model for accessing sort of structured data, or just accessing fields without having to use the record syntax and say, well, this author, it's an author, let me see the first name field, or having to use a prop list or dictionary or anything like that. You can just say author colon first name and be done. It's also nice because you can just put related functionality in the module that sort of has the fields, and you kind of have access to those fields, which is especially nice when you're doing something like validating data or applying business logic. So BossDB will support validations, which is good. So it actually won't save if your custom tests fail. So we try to use Rails conventions wherever possible to get people to. Sort of my plan is to find the one thing that's really slow in a Rails app, and then have the person rewrite it with Chicago Boss and point it to the same database and have them live side by side until Boss eventually takes over. So, for example, the table names are all just plural plural English nouns, and the ID field is just call ID, and the foreign IDs are called object_ID, and that's one part of the Rails API I really liked. It's opinionated, but it's very predictable. So when you get into querying, you can say something like BossDB find, say the object type, and then this looks a lot like QLC and a parse transform, but it's much worse than a parse transform. We have a number of operators for querying, including set operators and match operators. And here I have an equal sign, but we have a number of actually UTF-8 characters that you can embed in your source code. So like a set, should have put this in the slide, but you can have like a element of operator, the little E thing. I can kind of make a shadow here. But you can embed that directly into the source code, which makes for a nice, clean-looking source code. I had to do all sorts of terrible things to the scanner and parser to make that actually work with stock Erlang. But it's pretty cool. It's very similar to a Link or LinQ or however you pronounce it in the Microsoft technology world. So another benefit of BossDB is we've got a built-in caching layer and connection pooling layer using Poolboy. So it's really easy to write an adapter for another database and take advantage of the caching and pooling mechanism. So I'm trying to get people to write as many adapters as possible because I think it's a really neat system. So there's another part of the BossDB API is an event system called Boss News. And what it lets you do is create what's called a watch. You say, it's just like an observer, but you can give it a string, and it'll parse that string and interpret that. So if I say watch message42.contents, that will invoke the callback whenever the contents field of the message with ID 42 changes. And I can replace any of this with asterisk. So I can put an asterisk here, and then it will invoke the callback whenever any message has its content changed. Or I can put a star here, and then it will invoke the callback whenever any field of message 42 changes. And what's really neat about it is it's actually tied into the cache system. So whenever a query is cached, it will create a watch based on the contents of that query, and then give it a callback. And so once the contents change, the callback will be invoked, and the cache entry will be expired, which is great because it means you never have to worry about cache invalidation logic. So it's a really nice win of having an event system built into your model layer. So you should use it. All right, finally, I'm going to give you some example code since we got some time. The Hello World application. You don't want to, or you can sort of get started without building a template, or if you don't know anything about Django Templates, that's okay. All you need to know is some Erlang to get going. So you just declare the module. Here's another place where we use parameterized modules, which I think is a really good place to use it, which is passing in, this is actually a simple bridge request object. and will give you access if you want the request method or you want any HTTP headers, if you want query parameters, you can get all those through rec in this case. And you're going to need it for all of your defined actions, so I think a pmod is really good here. And then you define what's called an action, and this will be the name of it. This is the HTTP method, and then a list of tokens that appear in the URL. And I'll sort of show you how a URL is parsed in a minute here. And then to return something to the browser, you just say output and then some data. And once someone hits that URL, it'll output hello world. It's very simple.
Which URL?
I'll show you in just a second. So each URL will map to an action, and then so it'll choose what function to invoke based on the URL, and I'll show you how that's broken down. To get a little more complicated, you can make a template. So this is a Django template with a variable interpolation. So you say a message for you, open braces, message, end braces, and then instead of saying output like we did before, we return OK, which is sort of the standard situation that you want to populate the template with some variables. And you can pass it a prop list, you can pass it a dictionary, and there are a few other, I think you can even pass it like a GB tree if that's how you roll. And it'll populate the template accordingly. And so, final, more complicated example is using a model. So here's what the BossDB models will look like. Also parameterized modules. You just say what the model name is, and then you have a parameter for each field in your model. And so it always starts with ID, because everything needs an ID. And then you can have contents, you can have the dates, you can have numbers, whatever else you want. And then in your code, you can create the parameterized module using new. And then since BossDB will create these accessor functions for you, you can say message : contents, and it will retrieve the contents of this contents variable here. So you'll notice I didn't define a contents function up in the model. That's all taken care of for you with BossDB, and that will have the same effect and give you the previous template that we saw with the custom message. So talk a little bit about how the URLs are parsed, since we got a couple minutes here. That falls under routing. So when you request a URL like this, by default it says breaks up all the tokens. Says the first token is the controller name, the second token is the action name, and then everything else will just pass to the action as a list of tokens for it to do whatever it feels like with. So that's kind of the default behavior. Makes it really easy so you can say /message/edit, and it will invoke the edit function of your controller, and so on. You can customize this behavior if you want. You can use regular expressions. So if you want to sort of take out the controller name, you can say, okay, anything that says let's show / have a sort of a capturing match here, you can use to route to an action that you want. And something that's pretty neat that we added recently is having named capture groups. So if you have a really complex URL scheme, you can use a regex to capture subparts of it and kind of stick them where you want. So you can have the controller name in there, you can have the action name, or you can have any other parameters. Now one little detail I've left out here is how it knows what to do with this ID key value pair. Because I haven't said anything about ID anywhere in this application, but this is a valid routing rule in Chicago Boss. So how does it know what to do with ID? We got $1. I can see that from the regex. I got $message ID, but where's that coming from? This is a neat little feature. The parameter names are actually inferred from the parse tree of your controller. So if you have a route like this that goes to message ID, it will go through the source code, say, okay, we've got this action named show, we have this control named message. How do we match message ID? It'll actually look at the variable names and transform this Erlang variable type or format, this is a camel case message ID, and say, oh, well, that's actually the same as this underscored version up here. That's a match. Let's take the contents of $1 and pass it as the only token in this action. So it's really nice for creating nice, clean-looking routes that map very cleanly to your controller logic, and that's just using more horrible tricks with the Erlang parser and friends. Yeah, so that's your overview of the framework. Thanks for listening. One last thing before I take questions. Chicago Boss is built with the following libraries. And you'll see a few of these I starred were actually originally developed for Chicago Boss. We've kind of broken out from the project. Little message queue, the template system, and other things.
Also, you support Elixir?
Yeah, so is that here? Yep. So recently we added some code so that you can write your controllers in Elixir if you so desire. And the rest of the API is exactly the same. So you can take advantage of all our plumbing, our session handling, email server, and so on, and just write your code in Elixir.
LLP support's on the way?
Yeah, yes, and Duncan's been adding support for Lisp flavor Erlang controllers as well.
Authentication.
Yes, so
I'd like to use these OpenID things.
yeah. So what you can do actually in your controller is so he was asking about authentication. So in your controller, I'll go back to Hello World. You can create a separate function called before that takes the action name as an argument, and it's invoked before anything else is invoked. So it'll say before index, do something, and that can either return a redirect or return some data. And it says, oh, so that's where you put in your OpenID authentication information.
Have you looked it up with, like, say, Google's OpenID or?
Okay, so no, there's nothing.
With their accounts, because that would save you a lot of bother.
Right. So there's nothing built in for doing that. I'm not sure if there are OpenID libraries out there, but it's really easy to integrate because whatever you return, say the user information, will be passed as the third argument into the action here. So in that way, you can kind of say, just by declaring an action with 3 arguments, you're effectively saying this person needs to be authenticated in order to access this, which means it has to go through this before filter, it's called. Yes?
Can you talk a little bit more about the nasty tricks you did for parsing?
Oh, sure. Well, part of it is, let me see the library list here. Okay, so Aleppo is actually, okay, the question was, what kind of nasty parsing tricks did we have to do to get all the features that we wanted? One is, so implementing your own sort of compiler or doing compiler hacks in Erlang is a little tricky. There are nice libraries for a scanner and a parser in Erlang. So you can scan Erlang tokens. And what we'll actually do, since we support these UTF-8 operators, is intercept scanner errors. It'll come back, the scanner will say illegal character at column whatever. And then I'll look at that, I'll say, okay, well, what was that illegal character? And I'll go down a table, and if it's one of these operators that we support, I'll replace it with an atom that effectively does the same thing. Or actually, it replaces it with a comma, and then an atom, and then another comma. So that if you've got left-hand side operator, right-hand side, that's actually replaced with left-hand side, comma, operator name, comma, right-hand side, which is a valid Erlang construction. So that was the first step. And then to really make that work, you got to pass in the scanner tokens to the parser. The problem with that is that the preprocessor EPP doesn't like scanner tokens. You can only pass it, or at least the API, with the API, you can only pass it a file that it will preprocess. But I had some scanner tokens, so we actually have, Aleppo was a little project I started to re-implement the Erlang preprocessor to work on scanner tokens, which is a much more sane API, in my opinion. And it works, but with a few little quirks that I can tell you about afterwards. But those are sort of, and then afterwards, it also does all kinds of code generation to add functions. So for example, with the routing I was telling you about, inferring, figuring out that this is message ID, it will actually, the compiler will scan all of these forms for the function names and then pull out these token lists with the variable names, create a new function called _routes that exports all of the function names with the variable names themselves, which are eliminated, or that the compiled beam doesn't know anything about. So I think those are sort of the big hacks that we did. But Erl syntax is a great library for doing code generation if you want to go down that dark route. Any other questions? Yes?
How do you handle like Ajax calls or doing other services? Can you do that in the same?
Yeah, so the question was, how do you handle Ajax calls? And you can do it like you do anything else. So instead of, I guess I should say, instead of returning OK, which will give you a template, you can return JSON and then some data, and then that data will be sort of munged and sent through MochiWeb's JSON generator. I think that's how it works. But yeah, you just return JSON, and then it's a nice Ajax endpoint.
You just change your route.
Yeah.
If you want to do it for that.
Yeah, so yeah, you can have a custom route, and then it'll take care of the content type and that sort of thing for you. Yes?
When's the book coming out?
Right after the PhD.
You would like to change the order.
Yeah, that's right. That's right. Yeah, write my own typesetting system first.
I wouldn't recommend that.
Sorry,
Just go another year.
Yeah, just making fun of Joe for writing his own typesetting system in the middle of his PhD. Any other questions?
So are there any like example projects that have been using Chicago Bus?
Example projects?
Yeah.
There's Kai Jansen here has been working on one, or at least he's been telling me about a sort of a forum and knowledge-based system that's being developed with Chicago Bots, which hopefully will be open sourced before too long. Mostly, it seems to be pretty popular for sort of intranet, quick sites that you can, you want to set up an internal tool, but you don't want to babysit it and manage it for the rest of its life. People like Chicago Bots for that because it's very low maintenance.
If it's like with this architecture, you've got like, if you've chosen React as your back end, then you can just go in on any front end anywhere and just find the same data. So it distributes that very nicely, doesn't it?
Sorry, what do you mean exactly?
If you've got React or some distributed database as your back end, then you don't need to go to that server to get your data. You can go to that server.
Right. Yeah.
It's got the
So
same
yeah.
back
So
end,
web,
you've
yeah.
got
Web
distributed
web
data
applications,
automatically.
yeah, scale out very easily like that.
You can scale out beautifully easily.
Yeah, it sort of uses the same. That's the strategy most web servers will use for having sort of shared nothing at the front end level. That yeah, I'm happy to reuse for Boss. Yes.
Not really a question, but a comment on your 90% saving. I created 4 websites for internal use and Rackspace, and it's like fire and forget. So they're up and running ever since January last year. Maintenance was like 3 hot code reloads per application, maybe that much, and hands off since then. They're just running and running and running, and really maintenance free.
Yeah, that's the power of Erlang. Absolutely. One question in the back.
How mature is WebSocket integration?
We support sort of 3 types of comments. So there is the native WebSocket support through Cowboy now. It's just sort of works out of the box. There's like a little broadcast function that I think has been integrated. I'll have to check, but we have a number of people using WebSockets and all that. I don't use it myself, so I don't really understand how it works, but they seem happy with it. One more question? Yeah.
So if you distribute your application across multiple Chicago bosses with React as the backend, how does the eventing stuff in the DB layer work if you've got lots of
Yeah, so great question. The question was, if you have a lot of front-end nodes, how does the event system for the DB layer work? And for that, you actually you define a master node that handles all the notifications. So in this case, I think those are routed through the message queue that'll just be sitting on one of the nodes. So it's eventually we'd like to go to sort of a masterless, replicated architecture. But now you got to say, here's the master node. I hope it doesn't go down, and it'll be in charge of all the sort of the shared services like that. Okay, well, I think we're just out of time. Thank you very much.